All right, let's get started. So our team is Peace, and the project that we're building is to allow user to visualize the performance of deep autoencoder. So what is a deep autoencoder? Before I jump into explaining what an autoencoder, I think I should start with explaining latent space. So a latent space is a magic space that you know it exists, but you do not get the opportunity to just directly observe it. You just know that you just know it exists somewhere in the world, but you cannot see it. Now I have a data set, an MNIST data set. What is an MNIST data set? It is a bag of image. Image of what? It's a image of handwritten digit. So each image is like a digit written on it, and different people write it, so it's going to have different styles. So probably a very messy one, a very neat one, a 7, a 4 that looks like a 9, something like that, right? Anyway, so each image, here's the assumption, here's the cool thing. With an encoder, the encoder is going to encode arbitrary image in the MNIST dataset and map it to a location in the latent space. So for example, this 7 over here get mapped to this location in the latent space. Yeah, and the magic job that the decoder is doing is to take the location in the latent space and generate its corresponding image. You have an encoder, you have a decoder. Those two combine when you put it in a tuple. That is called a autoencoder. Voila. Now the even more magic thing is going to come. After you use an encoder to encode an image to its corresponding location, no one prevents you from manipulating the location of this red dot. So you can change the red dot from here all the way magically to here. And now you pipe the location of this red dot into the decoder. The decoder theoretically is supposed to give you this 9. So here's a figure of an autoencoder. An autoencoder consists of an encoder and a decoder. Yeah? And now you have an input image. The input image, when fed to the encoder returns the location of the input image in the latent space. So this vector over here pretty much tells you where does this image is supposed to sit in this magic unobservable latent space. All right. If you do not modify the location and directly pipe it to the decoder, it's gonna get you an image that looks identical to the one that you originally give it to the encoder. But if you manipulate this vector over here and you pipe it to the decoder, it's probably going to give you something else. And let's see autoencoder in action using the web application that we have built. All right, so this is the homepage of our application, and here's a quick welcome message. And below down here, we have a brief introduction to what is Autoencoder, how to use our platform. And the last section is about the developers of this application. Okay, so now let's play with autoencoders. Here, a user can select a model from the list of autoencoders provided by model developers. And right now we have trained one MNIST dataset autoencoder and uploaded it for a third time, and each of them has its own configuration. If you're just trying to test out our application, for now, I would recommend you choosing the first one. And that brings us to this page where you can easily upload an image. Here we select number 3. Okay. You could do some quick editing over here and customize which part of the image you want to feed it to your encoder part. Once you're done with that, hit this upload button and encode it. Wait for a while for the backend to give us the response, and here it is. And decode gives you the output of the decoder. So now if I change the factor, hit the decode again, you can see the image now turns into a 6, which is fairly fascinating. And decode it again, now it gives us something like a 0, change it drastically again. I don't know, not a 6, but it's like tilted a little bit. And now I don't even know what this is. And you can reset back to its original encoded compressed representation. Hit the decode again, it gives us back to the 3. You can also download the image, save it somewhere else. Yeah, that's from a generic user's perspective, how they're gonna use our application. All right, from a model developer's perspective, I would probably want to provide my model, the model that I developed. And how are you going to do that? Well, assuming you have already signed up for our platform, you can log in. And here it is. I'll log into my account over here, and after you log in, it's going to redirect you back to our home page. Here you can see a provide your model button. You click it, you can provide a name for your model. I'll call it MNIST test. A short description of the autoencoder for the sake of this test, if you will. All right. Now I can select the file. The input height and input width is 28 by 28. Number of factor is 8. Here you can specify the range of each axis of the compressed representation, which I'll just leave it at default because it's just a test. I'm not going to waste time to just modify it, each of them. Here you can provide the customized tag for this model. So this is a test. I'll add test to the tag. And once you have done that, you can submit it. Once it's done uploading, it will redirect you back to this upload image page where you can select the image for a quick test and encode it. If it exceeds the expected range, it's going to show a warning. For now, I'm just ignore it and then decode it. It gives you the same thing back. Changing it, decode it again. Now it's a perfect 3. Now we're going to explain the technology that we are using. The purpose of backend is threefold. The first one is to store user uploaded image. The second one is to store the user uploaded model. And the third one is to handle encode and decode requests that is coming from the front end. And the library that we use to achieve these are Django and Django REST framework. All of them are written in Python. In order to run the deep learning model, we require all the model developer to convert their trained model into Open Neural Network Exchange, ONNX. And our backend will directly take that serialized model, pipe it through ONNX runtime engine, and run the model using ONNX runtime engine. The entire backend is currently deployed to DigitalOcean.
Hello, I'm Ian McDevitt from Team Peace, and for the front end, the programming languages we'll be using are JavaScript, HTML, and CSS. For the library, we'll be leveraging React Native to create custom components, buttons, and slide bars. Using Axios, we'll make HTTP requests of the hard-coded image in the front end to the back end to receive the latent vector. The user will then manipulate the latent vectors via the slide bars and have Axios send an HTTP request back to the backend to generate a new photo. In the future, we'll have the users upload their own photos. The front end is currently deployed using GitHub pages.
My name is Lian Liao. I will present about our testing technology. We separate it into two parts. One is unit test for backend and behavioral test for front end. For the unit test, go to our Django backend report, and then activate our Python virtual environment and download test file into files folder. The test file is provided in our GitHub. See the complete guide in the image. After that, we can run the command to test our API and database. And then if you see OK, that means our backend operates correctly. For behavioral test, just like unit test, active our Python virtual environment and go to our React front-end report and go to our test folder. We use Selenium and Google Chrome as browser to test our website, so you have to install them before you test. See the image for guide. After that, just simply run the test file made by Python. And test 1 is for the main function, test 2 is for login system, and test 3 will test most of the elements on website. And while you're running, you will see the browser automatically testing for about 30 seconds for each one. If there is no issue, you will see pass, otherwise you will see fail. And that's all for testing. Thank you.
In our project, we utilized the Django framework for building the backend, which is a popular and powerful Python web framework. We employed the Django's built-in testing tools to test our application, ensuring its performance is stable and reliable. Throughout our testing, we focus on encoding and decoding core REST API functions. The REST API is an architectural style for web service that allows for easy data exchange between different systems and applications. By writing test cases, we can ensure that our API function properly in terms of creating, reading, updating, and deleting data, providing a reliable data source for the front end. As we conducted tests, we performed through testing on each API endpoint to ensure they function properly under various conditions. This way, we can be confident that our application will provide stable service to users. In summary, our backend development and testing efforts through leveraging the Django framework and built-in testing tools have ensured the stability and the reliability of the project's core function and API interfaces. This is for our front-end development and user experience, allowing us to build a high-quality web application.